Today we're going to talk about the DISC method. Now recall that to find the volume of an object, 3D object, you take the area of the base times the height. So now we're going to translate that into a disc-shaped object. So basically we're finding a representative rectangle inside our shaded region. We're going to rotate that around the axis it is flush with, and it's going to form a disc, as you can see in this bottom shape. And the disc has a base that is a circle, so you find the area of the circle, and you times it by the height of the disc. In this case, the height or width of our disc is going to be infinitely small, so it's going to be our dy or dx. So this is the area of the circle, which we know the formula for area of the circle is pi r squared, and then this is our width or height, as I did up there in the formula, and that's going to be our dx or dy depending on which direction it is. If it's a change in the x-axis or a change along the y-axis. Now to find the volume, I'm going to integrate from the beginning of the shaded region to the end of the shaded region. So integral from a to b of the area of the circle. So area of a circle. Now remember, the area of the circle is pi r squared. R for our problem, our radius is going to be the height of our representative rectangle, which is usually our function. So we're going to use the notation to represent that as r of x. And remember, it's pi r squared, so we take that radius and we square it and we times it by pi. Now since pi is a constant, I'm going to go ahead and factor it out of the integral. And then we times it by the width of our representative rectangle. Now this is a change in x, so we're going to multiply this by dx. Okay, so again, it is pi, the integral from a to b of pi r squared dx. Now these are going to be objects that are flush with the axis of revolution, and notice that our representative rectangle is perpendicular to our axis of revolution. So that's in the 2D object. Here it is in the 3D object. This would be our r of x, and here is our axis of revolution. Notice it's perpendicular to it. Okay, let's look at our first example. Find the volume of a solid of revolution generated by revolving the region bounded by the graph of y equals square root of x, the x-axis, and the line x equals 5 about the x-axis. So we're going to rotate about the x-axis. So you always want to start by drawing the picture, just like we did in Calculus 1. So we're going to draw the picture. We're going to do our square root of x. We have our line, or our x-axis, and then the line x equals 5. And we're going to revolve around the x-axis. And our area of interest is this. So our representative rectangle is going to be perpendicular. So here's our representative rectangle. It's perpendicular to our axis of revolution, is flush with the axis of revolution. And so now we know that's going to form a disc or a circle. So we're going to use our formula for the disc method. So we need to figure out where we start integrating to where we end it. So that's going to be from 0 to 5 of pi, and I'm going to go ahead and bring that out. Our radius is the height of that graph. That's going to be our function square root of x squared dx, because our width of that represented rectangle is the infinitely small change in the x value. So simplifying this down, we get the square root of x squared. This becomes x, and so we can easily integrate that. And then evaluate that integral from 0 to 5. Plugging in the 5 squared is 25. So we get 25 pi over 2, 0 plugged in, this is 0. So that'll be our answer. Okay, you try this one. We're going to let R be the region bounded by the curve f of x, the x-axis in the line x equals 0 and x equals 2. We're going to find the volume of the solid revolution attained by revolving the region R about the x-axis. So again, start by drawing your picture. Okay, we're going to draw f of x, which is a parabola. Move to the left one. The line x equals 0 and line x equals 2 is the next thing we need to draw. And so the region between that would be this shaded region. We're revolving around the x-axis, and our representative rectangle is here in the purple, And so it's perpendicular and flush to our axis, so we're going to use our axis of revolution. So we can use the disk method. So setting this up, we're going to figure out, well, first we got to figure out where it integrates to. So we know from 0 to 2. So we got to find our r. R of x is going to be the height. So then in this case it's just the f of x squared. And then our height or width of our represented rectangle is a change in x. So our volume is going to be pi integral of r squared dx, and we're going to integrate this from 0 to 2. I forgot to put that up here. So a quantity squared is just that quantity to the fourth. Now we could multiply x plus 4 out 4 times, but we could use u sub here because we know the derivative of x is just 1, so du equals dx. And so we can easily set this up for integral by u sub. We need to remember to find our new upper bound and our new lower bound. So let's rewrite this equation as pi times the integral from 1 to 3 of u to the fourth du. Integrating that, we get pi times u to the fifth over 5, evaluated from 1 to 3. Plugging in the 3, we get 3 cubed over 5, which simplifies down to 243 fifths pi minus 1/5 pi, which is just simply 224 pi over 5 would be our volume. Find the volume of the solid generated by revolving the region bounded by y equals the square root of x, the line y equals 1, x equals 4, about the line y equals 1. Okay, so we're doing it about a different line. So again, start by sketching your graph so you know exactly what's going on. You can find your shaded region, you can find what's being revolved around. So there's, again, y equals the square root of x. Now we're going to y equals 1. And now let's draw the line x equals 4. So our shaded region is going to be where those 3 lines meet, so here in the green, and we're going to revolve around the line y equals 1, the red line. So our representative rectangle needs to be perpendicular and flush to that, so we're going to use this representative rectangle, and it's the change in the width of x, so it's dx. All right, so now we need to figure out our radius. Our radius is not just the top function this time because we're revolving around the line y equals 1. If I did it to f of x or to y equals square root of x, this would be the representative rectangle. But we don't need all that. We need to take that and we need to subtract off this part, which is a height of 1. So our r of x is going to be our function minus 1. So that's going to be our radius of their representative rectangle. So now the volume is going to be pi, the integral, and now we got to figure out where these 2 functions intersect. You can easily see that they intersect at 1 on the x-axis, or you can solve this equation. And we know that they also intersect when x equals 4. So we're going to pi times integral from 1 to 4. Of our r of x, which is the square root of x minus 1, quantity squared, times dx. Okay, we wouldn't want to use the u sub this time because we wouldn't be able to cancel out that x if we make the square root of x minus 1 as our u. So we're going to have to multiply this one out. So I need to take the square root of x minus 1 times the square root of x minus 1. And when I multiply that together, I end up with x minus 2 the square root of x plus 1. And now we can integrate that. And we're going to evaluate that integral from 1 to 4, so plugging in 4 in place of every x. Four to the 3/3, 3/2 times 4/3, it simplifies down to, well, I'll do 4/3 times 8, because let's just do it step by step. And then plug in 1, that gives us 1/2 minus 4/3 plus 1. All right, so 8 plus 4 minus 4/3 of 8 simplifies down to just 4/3. And 1/2 minus 4/3 plus 1 simplifies down to 1/6. And 4/3 minus 1/6 is 7/6. Therefore, our volume is equal to 7 pi over 6. Okay, you try the next one. Okay, hopefully you started by sketching your graph. Okay, the graph of x equals 2 divided by y is the same as the graph of y equals 2 divided by x. And so it's going to be a rational function that looks similar to this. And then our next part is y needs to be between 1 and 4. So we got y equals 1 all the way up to y equals 4. So I can disregard this bottom half of the graph. I don't need it. And we're going to revolve around the y-axis. So this is our area that's in between that. So this time when you draw your represented rectangle, it's horizontal. And so the thickness of that, or the height of that, is dy. And so we're now going to be in terms of the y variable. So everything needs to be in terms of y, not x. All right, so let's set this up. So first thing I need to do is figure out what my r of x is. So my r of x is, r of y, sorry, is 2 over y. And then to find our volume, that's going to be pi times the integral. And then we need to find our smallest y to our highest y, so that's 1 to 4, of our r of x, which is 2 over y, quantity squared, dy. All right, so let's distribute that square. And now let's integrate that, so I can rewrite 4 divided by y to the second as 4y to the negative 2 power. And then we just use our power rule. Factor out that 4, and then the integral of y to the negative 2 is just negative 1 over y. Evaluate from 1 to 4. So I get 4 pi minus 1/4 minus a negative 1 over 1. Minus minus becomes a plus, and so we got 4 pi plus 3/4 times 3/4, which is simply 3 pi.